My name is Ellen Bent. I'm a designer, researcher, and lecturer at Niederrhein University in Mönchengladbach, Germany. And the topic of my presentation today shows that it goes a little bit in another direction than the other presentations that we have seen before. And my agenda for the next minutes will be, I hope I can switch here. Yes. That I give you a short introduction to our university and a deeper insight to the special project. It's called HanfKnit, or in English, HempKnit. So our university is located close to Düsseldorf and Köln at the western part of Germany and very close to the border to the Netherlands, Belgium, and France. And it's located in a very old and traditional textile area. As you can see here, we have two locations, one location in Krefeld and another in Mönchengladbach. And our faculty is textile and clothing technology is in Mönchengladbach. And you can see here our main building in former times, more than 100 years ago, surrounded with all the other textile industries that were located there in that time. Nowadays, the building is still there. The sky is blue now. I'm very happy for that because the companies around are more sustainable now. And we have still a lot of textile companies, but more focusing on technical textiles. Our university is the largest and best known department in the field of textile and clothing technology in Europe. And we are teaching and researching in all areas from the fiber to the final product. We have about 2,000 students at our faculty and several laboratories, professors, and employees. We offer several degree programs for bachelor and master students. What is special at our university is that our designers are not only designers in textile or fashion, they are design engineers. So they get the technical knowledge to develop and to design products with them in their way to the bachelor or master program final years. Yes, the heart of our universities are our laboratories. As I told you, we have the possibility to start with the fiber. So it's possible to do your own yarn, your own fabric constructions, or other textile things like analytics or textile chemistry. We have the possibility to print or to do several types of confection technologies. And of course, we do virtual design and product development as well. And for that reason, we have our own research institute with a real sustainable focus. And here are just some selected samples of research projects running at the moment along the textile chain from, for example, the focus on new resources and products or product development or textiles and transport or logistics or textile mission, what will happen to the materials if the consumer is using it in the household washing, or for example, the big topic circularity or circular economy. And all this together shows that there is a possibility to work and to research along the whole textile chain. One big project is Textile Factory 7.0. It's a development of an industrial park of the future, and that means that we want to bring back textile industry back to Germany in a reasonable way, in a sustainable way. And a good sample for that is the project HanfKnit, that I will present you now in a little bit deeper. So the project is about the design and development of a special locally produced recyclable zero waste jacket made of hemp. The research project is supported by the ACT EU program. It's a special program that was launched as a reconstruction aid to cushion the economic and social consequences of the COVID-19 pandemic in Europe. And we are in a program for North Rhine-Westphalia. This is our county. And we are supported in the framework of the European Regional Development Fund. So the target is to strengthen the local bioeconomy in North Rhine-Westphalia, to show that nearshorings with local resources, companies, and partners is possible with sustainable projects. And as a study case, we are working on the design and development of a locally produced recyclable zero-waste jacket made of hemp. So in the project HanfKnit, we have a local partner. You can see here our location, and nearby, just on the other side of the border from the Netherlands, France, and Belgium, we receive the fiber material for our project. And from Germany, we have hemp fibers as well. To be sure that there is no problematic or polluting way to do the fiber processing that is needed to put it or to prepare it for a textile process, we work with a company close by in Tönnesforst because we want to be sure that there is a closed water and chemical cycle. Because if you have fiber material like hemp or linen from other markets like China, there is always the big problem that the method that they use there for fiber preparation pollutes a lot of water and sometimes a whole landscape. And to be sure that that will not happen in our supply chain, we work with this local partner. At our university, we are doing the concept for the design project, and we are doing the yarn at our spinning plant. And as a partner nearby for the knitting, we have Bache GmbH. It's a company that is specialized on 3D knitting. That means seamless knitting without waste. And another partner is company Litres in Düsseldorf. They are a retailer for outerwear and workwear, and they will bring, hopefully, the product in the end to the market. So first of all, we need a design strategy, and we want to design for sustainability. So we did a kind of, we pointed out the key points that we want to match. So first of all, fiber selection was very important. To get 100% hemp was the idea, because it's a traditional fiber that was cultivated in our area for a long time. And so it's a local source. And we want to blend it with lyo hemp. This is a pretty new regenerated fiber type that is made from hemp straw. So that means the residues of the fiber process we use for another new fiber type. It's produced at the moment in lab scale at Thüringisches Institute for Textile and Plastics Research, and we could get some material for our research project. Then we wanted to have complete transparency along the entire supply chain. That was easy to manage. As you have seen, we are very close together. Then in the next step, we want to be sure that we have a zero waste production. So we want to produce seamless or fully fashion and knitting technology. The advantage is that in knitting, you start with one thread. So we have the possibility to shape the product during the production process, and you do not have to cut or to sew or to do other things like that. This is very sustainable and was another focus. We want to reach a really high wearing comfort because of the natural performance of the material. So we hope that it will work with the very good properties that hemp has. We were developing a functional clothing concept. It's a body mapping concept that you use to create special functional areas in the product so that you have a really individual product in the end. And we want to use only natural colors in the beginning. We will, during the project, we have another 3 months to go, do some dye tests, but we prefer in the first step to work just with the natural colors done by nature. Then we would like to check whether it's possible to have a special sustainable functionalization. We can do a wet finishing test at our university. For example, we want to test fluorine-free hydrophobic finishing. And in the end, there is another point. We are using a special knitting technique. We have no seams on our garments, so we have the possibility to wear it with inside out. You can wear it from both sides, and that will be very sustainable as well, because we can use it for different applications. So the complete design concept was targeted for the targeted functional jacket is based on an ergonomic concept of our body. That means that we are looking at the temperature and moisture management of the body in action for different kind of activities. And then we decided to create a jacket with different functional areas, and each area shall have a special property in the end. Like, for example, on the shoulders, we want a kind of padding for people that wear backpacks, or we want some permeability to air. That is something under the arms, for example, or in the back, or some abrasion resistance at arms or at the sides, so that we have a long-lasting product in the end. Yes, but first of all, we had to choose the fibers. We decided to take hemp fibers because of their very special properties. There are several advantages that hemp has. It is easy to grow with sustainable cultivation factors, like, for example, low use of fertilizers and pesticides, and the possibility of local cultivation in Europe. This is very important, so that you don't have to move it from all over the world here to our place. 1 hectare sequesters 9 to 15 tons of CO2. This is much more than cotton can manage. And we have a very low water consumption of 2.5 to 3.5 liter per kilogram. This is much less than cotton has, so those are very important factors for sustainable cultivation. There's one problem to solve if you want to use bast fibers like hemp. It's never present as a single fiber, but as a fiber bundle. This you can see here on the right-hand side, for example. And so the main challenge is to separate element fibers in a sustainable way. And we really want to be sure that there is no harm for the environment, no pollution of water. And as I told you, that was the reason that we choose a partner nearby at our university. Another point that we were focusing in hemp is that we really could see that the cultivation of hemp is growing again. It's a traditional fiber, it's a European fiber, and as you can see here, at the moment, France is the main is the main cultivation area, and Germany is on the 2nd place in Europe. And it's increasing because I think industry, and not only the textile industry, there are many other possibilities to use hemp, has found out that it has a great potential and very good sustainable properties. So this is how we started. We were selecting some summer hemp, an unbleached hemp fiber and a bleached hemp fiber. This is how it looks like when it is prepared for the textile industry. And we have as a third component the lyo-hemp fiber, that is a lyocell fiber based on hemp straw, as I explained before. So the next step after the fiber selection was the development of yarns in a spinning process. And we were first of all thinking about what is the best process to use. And we decided to use the rotor spinning process because it has several advantages. It's quick. It has a reasonable price in the end because our product needs a reasonable price in the end. And it creates a yarn type that is really good to use on our product. So you can see here the production chain at our laboratory. We start here on the left-hand side with a mix of the fiber material, and we end here on the right-hand side with the produced yarn in different variation. So the yarn variation that we developed were in different counts and different constructions and different blends. we always mixed and blended the summer hemp with the hemp material to find out what are the impacts on the property of the material and later on in the product. And as you can see here, we create first raw slivers, and then it's easy to pick up that this unbleached hemp leads to this yarn and the bleached hemp to this yarn. So there were several things we can test now. So on the next step, we go to the knitting development and the fabric construction. We went to our partner, it's Bache GmbH in Rheinberg, and it's a German knitting company, production 100% made in Germany with green electricity, and they have about 25 flat knitting machines with different gauges, and they are completely specialized on seamless 3D knit, and that means that it's the perfect partner matching with our project. Together with them, we developed several knitted fabric types with different functionalities. We were doing a research on workwear, on different kind of knitwear, and we selected several constructions. We realized the materials to compare it in a way, all in a summer hemp unbleached blend with lyo hemp in a ratio 80 to 20 in a normametric 10, and a 100% lyo hemp normametric 22, to combine it in the fabric construction in a special plating technique so that we can find out how we can improve some functionalities in special places in the fabric construction and in the body mapping concept. In the end, we selected 4 constructions that you can see here: plain knit, a 2x2 rib, and links strip. And for a better air permeability, we had the patinate pattern here. And all in all, you can see here, it's all in the same material, but we have different thicknesses and different weight and different functionalities. So that was the idea of the whole story. And then we had to prove, is it really like we thought that it is? So we have to do some analytics of the surface and of the performance of the material. And the performance tests were really exciting for us because we were thinking about how we can do the test, the best test setup. And we decided not to use the traditional abrasion test for clothing, but for technical textiles, because we want to create a product that should be usable for workwear in the end or for sportswear in the end. And so we used the test setup for technical textiles and with a very strong impact during the test procedure. And you can see on the left-hand side, this is a plain knit before and after 20,000 rounds of Martindale test. And that was really astonishing for us because we had to break up the test because the material was still lasting. And the material loss was very good as well. And the same for the air permeability. So the only material that was a little bit weak is the patinate pattern with the holes in, but that makes sense. And it's still abrasion that it's much better than any standard cloth material. So that's not the problem. To have a first reference, we used a standard sweater in plain knit in 100% cotton. And as you can see here, in the very first test with this reference, our hemp material was much better in the performance than the cotton material was. So this is really very interesting and very exciting for us. So we took our materials, we will know now what are the performances of the different structures, and now we put the materials and structures in our body mapping concept, and this is a prototype that we are preparing at the moment. It's still under construction. I'm very sorry. I think next week it will be ready for the very, very first test. And yes, so maybe next time we see, I can show you the whole garment. but this is a concept for this time. And so we have the padding with the links rib on the shoulder. We have the fitting and the abrasion resistance at arms and body. We have the ventilation area here below the arms and at the back, and the rest of the whole garment is in plain knit. So while our prototype is under construction, that means the programming for the knitting machine is done and the whole fabric connections, and we have to test whether the structures match with each other in the right places. We are thinking about further body mapping concepts for other activities, and we did a test, a very, very first test. This is what I can show you now. This is this knitted cap, because this is done seamless in 3D, so it's completely coming out of the machine like this, and that was another very important step for us in this project, because if you can knit a 3D surface, that is never sure. Even if you know that you have a 2D surface, that does not mean that it works with 3D, because you have other impacts on the yarn, on the knitting machine, and that was a very good step for us, and we are very happy with that. So what are the next things to do? We have still 3 months to finish the whole research project. So we go on with further spinning tests. We want to test winter hemp. It's a completely different hemp fiber. It's finer, and it has several advantages if you compare it with a summer hemp. But we want to do further variations in the finishing of the summer hemp fibers and yarns. We want to go on with the knitting for further development tests and for shaping, body mapping, and of course to find in the end maybe a small collection and not only one garment. And then this is very exciting. Next week we start with recycling tests, because our main goal is that we have a circularity in the end, and that will be the focus for an additional project that we are planning at the moment, that we would like to take our material now and the final product and to do a mechanical recycling to reach material that we can respin on our machines in the end again. That will be the target for the future. Yes, so far these are my sources, and the imprint shows you that we are a big team. So I'm not on my own. Of course, I have several colleagues working with me, so spinning experts or finishing experts, and we have a lot of students with us in our research project. This is part of our study program, that they have the possibility to work in the research project with us, and the partner at company Bache, there's another team of 4 persons. So it's only one prototype, but a lot to do. So I'm ready for your questions, and yes, let me know whether I can answer something.